Professor Wergeles here. We are almost finished with this complete application. I put some lines here so we can focus on the minutes hand. I'm going to get rid of those. And now we are going to clean up the code so everything looks good. I have a set interval for my seconds hand. I also have a set interval for my minutes hand. Now I could put all of these in one, but you can imagine the code, especially if I have all these variables and different selectors. It could get messy unless you organize the code correctly. So having different set intervals for each hand may be a better approach. In addition, they're all independent of each other. Because honestly, for seconds, I need to check frequently. But for minutes, maybe I don't need to check every second. Maybe I can check every 30 seconds. So I can have these independent from each other and use less resources. And for the hours hand, maybe I check every 15 minutes. You don't have to check every second. But in this example, we're just going to keep it simple. We're going to have each one check every second. So this is going to be our hours hand. And as I said in the previous video, it's a little bit more difficult to calculate this formula. But first, let's get everything set up. I'm going to use a set interval function. That takes two parameters. One is a function that's going to get called. The second is the duration. So I'm going to call this every 1,000 milliseconds. And I'm going to end this function call with a semicolon. Once I have this set up, I'm going to put a new line here and code the functionality. Now think about this. As I said in the previous video, my clock says 6:33. So when it's 6:30, the hours hand will be in between the 7 and the 6. It'll be halfway. When it's 6:45, it'll be more towards the 7. When it's 6:15, it'll be more towards the 6. So we need to actually calculate that in some way. So how can we calculate that? Well, if I need to determine it's 6:30 and put that in the middle, I need to know what hour it is and also what minute it is in order to determine where the hour hand should be. So I need to grab both. I need to grab hours, so I can call the date function, and I can say get hours, which you'll see right here. Now that hours is going to be local time based off the system clock, and I can also grab minutes again. So I can say get minutes, and that's a function, so it has parentheses, and then do a semicolon. Now let's think about this formula. So just like we had before, I have 360 degrees. And with hours, you'll see I have 12 tick marks from 1 to 12. So I have 12 increments per rotation, and the clock face is 360 degrees. So I could do a simple calculation. I could just say 360 divided by 12, and that's going to be equal to 30. But let's see how this plays out. So I can create my hour degree equal to the hours multiplied by 30. And then I can create my hour rotate, which is equal to the rotation function with a dynamic parameter, which is going to be our h degree. And then close that function. And then I'm going to use jQuery. I'm going to select the hour ID. And I'm going to use the CSS function just like we did before. I'm going to provide a JavaScript object, which is going to call the transformation with the hRotate function that we made. And let's see how this plays out. So I'm going to refresh. You'll see it's not rotating. Why was the minutes hand not rotating? Well, I forgot the unit. So let's put the unit, which is going to be degrees. Refresh. You'll see the hour is at 6, but it's 6:35. So if you go to your clock at home, when it's 6:30, the hour hand is in between the 6 and the 7. So if the clock's working, but it's not working as a traditional clock would. So what do we need to do? Well, let's just think about it logically. If it's 6:30, the hour hand will be in between the 6 and the 7. Well, how can I go in between the 6 and the 7? Well, first, let's formulate this problem. Now we see that the hour hand does not move in hour increments. So the problem is not that simple. The example we've been using is, let's say it's 6:30. The hour hand will be in between 6 and 7, so we have to calculate based off minutes as well. But what's the calculation? Well, if it's 6:30, I need it to be in between the 6 and the 7, so I need to move it halfway. Well, what's halfway? So let's say it's 6:30. I need to move it how many degrees? So the minutes hand will be 30 ticks around at 6 degrees. So it'll be 180 degrees. And I need to move the hours hand 180 degrees plus a little bit more. So let's say I take the minutes and divide it by 2. The minutes will start from either 1 or go all the way to 59. So if it's 1 divided by 2, it'll be 0.5. And if it's 59 divided by 2, it'll be 29.5. So let's say it's 6:30. Well, 6:30, the seconds will be equal to 30 divided by 2, which will be 15. So I can take whatever the hours hand is, which is going to be 6 multiplied by 30, so it's going to be 180 plus 15 degrees. So if I add 15 more degrees, let's see what happens. So essentially, we're going to add the current number of minutes divided by 2, which should give us a number between 0.5 and 29.5. But the question is, can the set rotate function handle decimal numbers? Let's come back. And in this example, they're taking 20 multiplied by pi divided by 180. Most likely that is going to be a fraction. So the angle can be a decimal value. And we can test that as well. If we add this here, we'll do plus mins divided by 2. Let's see what happens with our clock. So if I do a refresh, you'll see it's now a little bit past 6:40, and the 6-hour hand is closer to 7. So the rotate function can handle floating point numbers. Well, let's use another example. Let's say the hours is equal to 3 and the minutes is equal to 30. If I refresh, you'll see the hours is in between the 3 and the 4, exactly in between. So if I calculate to 3, that's going to be 1, 2, 3, 4, 5, 15 ticks at 6 degrees apiece. So that's going to be 90 degrees. So I have 90 degrees, 180, 270, 360. So if I have 90 degrees plus minutes divided by 2, so I have 30 divided by 2 plus 15 more degrees, that is going to be right in the middle, because in between 3 and 4, so this is 90 degrees, and I have 1, 2, 3, 4, 5 more degrees, so that's going to be 30. So every hour is 30 degrees apart. And if I do minutes divided by 2, it'll be 15 degrees, so it's going to go right in the middle. Or let's say I have minutes divided by 59. Well, this hour hand is 30 degrees apart. If I do 59 divided by 2, it's 29.5, so it'll be right next to the 4. Or let's say it is 10 minutes. 10 minutes divided by 2 is 5. So I'll add 5 degrees, which is going to be close to the first tick mark. So if it's 3:10, it's going to be close to the first tick mark, and we can see that. Now notice when I adjust the minutes here, it's not adjusting the minutes hand. It's only adjusting the hours hand, because the minutes hand is in its own set interval function. We're only changing the hours hand here. So if I put it at 10, you'll see it's right by the first tick mark after the bear moves out of the way. You'll see it's pointing close to the first tick mark at 5 degrees. So if I do 3:12, it should be right at the first tick mark. It's pointing right at the first tick mark, which is 6 degrees. So I have 1, 2, 3, 4, 5. I have 5 ticks. They're 6 degrees apart. So every hour is 30 degrees apart. If it's 30 minutes divided by 2, it's 15 degrees. So it'll be right in the middle. And that's why I do the minutes divided by 2. So our formula is correct. Let's make sure this is programmed correctly. So I have hours multiplied by 30, because there's 12 hours, needs to go 360 degrees, and then plus minutes divided by 2. All the hours are 30 degrees apart. So if I divide by 2, I can go right in the middle. So that's my formula. I apply that in the rotate function, which can handle floating points. And now I need to make sure it works for all browsers. So I'm going to use the MOTS transformation, followed by my function hRotate, followed by WebKit transformation, followed by the hRotate, and then the last is the default. So I have my Mozilla transformation, my WebKit transformation, and the default transformation, followed by the closing parenthesis for the CSS function. If I refresh the clock and put it back to be dynamic, refresh the page again, my clock says 6:48. Here it says 6:48, and you'll see the hour hand is really close to the 7, because 48 divided by 2 would be 24. In between each hour is 30 degrees, and I'm at 24, so I'm really close to the 7 hand. And that's why this formula works. Now, every time you're finished coding, make sure you go back and clean up the code. You don't need all these spaces. Make sure all the tabs are nice and neat. Make sure the TAs can read your code. Make sure you put some comments there so we can understand your thinking. And the easier your code is to read, the easier it is to grade, the happier the TAs will be, and the better grade that you'll get. If the code's all a mess and you didn't tab it out, it's hard to read, we're not going to be able to find your solution, which makes it harder to grade, which has a higher probability for getting a lower grade. So hopefully your solution is similar. We finished the hours hand. We've saved the file. Every time I save, I'm going to do a commit. So I'm going to come back to the command line. I'll do a get status. You'll see the number 3 has changed. So I'll do a get add. Number 3, index, get status. You'll see it turns green. So it's being added to the stage and ready for commit. So I'll do a get commit -m. And we finished the hour hand functionality. Hit enter. You'll see we added 30 lines of code. I got rid of 20 spaces there towards the end. If I do a get log, you'll see I have all of my commits. You'll see there's a long list, so I can do a Q to exit out. If I do a get show, it shows you what we've added. I can look at all of it, or I can do a Q to exit out. Do a get status. You'll see nothing added to the commit, but there are some untracked files. So this is it for this lecture. We've looked at the position elements. We talked about the z-index. We looked at the set interval function. We have programmed our first complete application, which is a clock. We implemented HTML, CSS, and JavaScript. We looked at using Git for all of these implementations. Every time I save, I do a commit, and we have a complete application. So this example, if you want to use for a job interview, is a good example to show. I built a clock. Clocks are commonly used. You can build a digital clock. The functionality is there. Let me or the TAs know if you have any questions. That's it for this lecture. We're going to be moving on to the next lecture. So stick with Professor Wergeles, and we'll see you next time.